Alright, hi there everybody. So, this is going to be our second lesson on systems of equations. Last time we did our unit, our lesson was over graphing systems of equations. At this point we should be able to graph systems of equations both on graph paper and on and using our graphing calculators at this point. So yay! So you got some tools for doing for graphing systems of equations and finding the intersection or the solution of the systems of equations. This time around what we're going to be doing is we're going to be looking at the other two methods for solving systems of equations. So we have three methods ultimately. We did the first one, graphing. The other two are substitution and elimination. This video, I'm going to break this particular lesson. I'm going to break this into two videos. So you're going to have one video for substitution and one video for elimination. That way we're not doing like a 30-minute video here for you guys. This will be our homework assignment. We will do this in class together. I will probably have a worksheet to go along with this so you guys can have some more practice, because this is about, I don't know, like 15 problems or so. I'd like you guys to have a little more practice with this before we move on to the next part. Let's save these do now problems for in class. We'll do that as like an exit ticket or as a warm-up when we come back to class. So we'll come back to this page later. Let's go to the next page of our packet. So you guys saw this in our last packet. So the graphs of systems equations, what we're telling you. We have the intersecting lines. This is hopefully what we end up with most of the time. And that has exactly one equation, which is what we want when we're doing. And we call that the consistent and independent case. Our second case is the parallel lines, where these never intersect. This is what we call the inconsistent case, and we'll see that sometimes. And then our third case is when, through manipulation or through through multiplication, we end up basically with the same line written in two different ways, and that creates a dependent case, and there's infinitely many solutions. Okay, and we'll try to point out those. I'm going to try to keep us with the intersecting lines. I like the consistent and independent. It forces you guys to use the most algebra skills, and you guys know the answer is supposed to work out to something, whereas the other two ones are a little bit more technical when they occur. Okay, all right, so next page. So substitution. So we're at example 1 here. We're going to solve using substitution. Before we jump into this example, let's talk about what substitution is. Substitution is when we solve for a variable, and then we plug that variable into the other equation. Okay. So that is what substitution is. Okay, and let's go through how we go about doing this. There's really good steps here on how to do this. First thing we're going to do is isolate one of the variables. So we have our two equations here. Let me change colors here so you guys can follow along. Okay, so we have these two equations here. We have solved for one of the variables. So you're going to take a look at both of your equations here, and we need to isolate for one of the variables. In this case, the first one is given to us. We already solved for x. Yay, good. So we're going to take this value for x, and we are going to plug it in for x in the second equation. So step number 2, substitute. So we had step 1, isolate a variable. Step number 2, substitute the value of the variable into the second equation. So go ahead and write that down. You guys can hit pause whenever you need to, and you guys can enter that into the equation. So we'll end up with 1/2 times 8 minus 2y minus y is equal to 18. Alright, so that's step number 2. And then step number 3 down here at the bottom, we are going to simplify and solve for the variable. So we're going to go back to our equation here. We will solve this for y using our regular methods. You guys can pause the video, go ahead and do the math, and see if you guys match up with what I end up working out with here. And we're back. Cool. All right, so I finished solving this out here. Let me focus this a little bit for you guys so it's a little bit cleaner. All right, cool. So we started off, we plugged in 8 minus 2y. We plugged that in for x. So that ends up with this line right here. So we'll end up with 1/2 times 8 minus 2y, because that's our value for x. And then we subtract y, and that's all equal to 18. All right, so we're going to do our distribution. 1/2 times 8 gives us 4. 1/2 times -2 gives us -1. So we'll end up with 4 minus y from this y minus y here is equal to 18. And then we'll just simplify from there, combine these to get minus 2y. 4 minus 2y is equal to 18. Move all the constants to one side, all the variables to one side, so we subtract 4. Negative 2y is equal to 14. Solve for y, we'll get y is equal to negative 7. Now, we're trying to find the solution for the system of equations. This is only half of it. A solution of equations is a point. Remember, it's an intersection of two lines. So we need an x and a y value. So we found the y value. We'll take this y value and we will plug it back into one of our two equations, and we'll solve for the other one. This one's already solved for x nicely. So we'll take y is equal to negative 7, and we're going to plug that into x is equal to 8 minus 2y. And that will give us x is equal to 8 minus 2 times negative 7, because y is equal to negative 7. Distribute, we get positive 14, because a negative times a negative is positive. So we get 8 plus 14, which is equal to 22. So x is equal to 22, giving us a solution or a point of intersection of 22 and negative 7. If you were to use your graphing utility and you plugged both of these equations into like your graphing calculator, and then we went about finding the point of intersection between these two lines, and then we used our calculator or Desmos or whatever we end up using to find the point of intersection, we would end up with this as the coordinates of our line of intersection. So 3 steps: isolate a variable, plug it into the other equation, and then simplify for the variable. And then your 4th step that's not really written on here is we go about solving for the other variable, in this case x. Great. Cool. Awesome. Let me square this up a little bit. It's a little off. All right. There we go. Okay, cool. So there's your first example. Let's go to the next page. So we have a bunch of practice problems on this page. I would like you guys to try these here. I'm going to pause the video again. You guys go and do the same thing, and I want you guys to solve the first 3 or these 3 equations on your own. Remember, the first thing you're going to do is you're going to isolate the variable, isolate one of the variables, and then you'll plug it into the other equation. I will do, so number 1 here, I'll help you guys out here. The other ones, you already have one, so like number 2, the second equation is already solved for y. So we will take this value and we will plug it in here for y. This one here, they're both equal to y. So by the reflexive property, we know y is equal to y, which means we can take these two lines, 4x minus 5 and 8 minus 2x, and set them equal to each other and solve for x, and then we'll go back and we'll find y. Okay, let me help you with this first one here. I'm going to solve for c in the second line because it's a variable by itself. I don't have to do any division. So that means that c will be equal to 10 minus 3d. Okay, I would like you guys to go and pause the video, and I want you guys to try to solve each of these. I'm not going to put the work down here, but what I'll do is I will give you guys the solutions at the very end. I'll give you guys the answers here in the video, and you guys can check your work to see how you guys did. Alright, so go ahead and pause the video. Alright, we're back. So the answer to the first 2 problems, you should have gotten 1, 3 when you guys plugged in, you solve for, you take c here, you plug it into the other equation, so we'll take this value here, we'll plug it into c here, solve for d, you'll end up with 3 for d, plug it back in here, and you'll get c is equal to 1. For number 2, you should end up with the point 13, 17 for x and for y. Okay. If you guys didn't get those, give those a try. If you need me to, I can go through these in class. I want to take a look at number 3 together because number 3 does not work out to a pretty answer when I checked it on my calculator. So I'll show you guys the setup and we'll try solving it ourselves and we'll see what happens. So like I said, these are both equal to y, so we'll just set them equal to each other. So we have 4x minus 5 is equal to 8 minus 2x. We'll solve this from here, so we'll get 6x. We'll add 5 to this side. Let's see here, that's going to be 13. So x is equal to something ugly, which is 13 over 6, which is a really ugly number. Okay, so we're going to take that and we're going to plug it into one of these 2 lines. Let's see which one do I want to use here. I'm going to plug it into the bottom one because this 2 will then divide into the 6 and it'll simplify it a little bit for us. If you guys don't see that, you can do this with either one. You should end up with the same answer either way, but I'm going to plug it into the bottom one. So we have y is equal to 8 minus 2 times 13 over 6. Okay, that'll give us 8 minus the 2 divided by 3. I'm sorry, 2 divided by 6 is 3. So this will be 13 over 3 when we simplify it. This is over 1. I want to simplify that some more. So 3 times 8 is 24. So it gives us 24 over 3 minus 13 over 3. When I simplify that, 24 minus 13, what is that going to be? Is that that's 11, I believe? Right? do some quick math here. Yes, it's 11. So I get 11 over 3 is what y is equal to. Two really ugly numbers. So my final point here should be 13 over 6 and 11 over 3. Okay, so there you go. 3 examples for you guys. If you guys did not get those answers, try the problems again. It's worth your guys' time. That's why I have the flip video. You guys can go back through and do them. These ones up here, I've shown you how to plug them in. So this one's already solved for y. Plug it in for y. This one, you already solved for c. Plug it into the other equation for c. Solve for d. Work your way back through to find the other variable. All right, we'll go on to the next page now when you guys are ready. Alright, so we have another equation here. Let's write both of these down. So we have y is equal to 2x minus 3 and 2x minus y is equal to 5. First thing we need to do is we need to isolate a variable. This first one's already isolated. We'll plug it in and we will get 2x minus 3 because that is what y is equal to. Be careful with the negative there because you have to distribute that negative through. This whole thing is going to be equal to 5. So I'm going to have you guys finish this problem from here. I'm going to pause the video again and I'll give you guys the answer over here and I'll work out the scratch work so when you come back everything will be done and solved for you. Okay, here we go. Okay, here we go now. So we did 2x minus 3 is equal to 5. We distributed through. The 2x minus the 2x is equal to 0. And then we add 3, and it's equal to 5. Well, that's a problem, because that means 3 is equal to 5. That's not good. We can't have that happen. That doesn't make any sense. So we need to look at what's going on here really quick. 3 does not equal to 5. This is not a true statement. It's not possible at all. So we need to go back through and look at our equations here. This doesn't mean we made a mistake. If we go back to our earlier note sheet here, let me see if I can find it really quick. This one right here. So you have this sheet right here. This is a no solution scenario when we have 3 is equal to 5. So it's no solution. So this means that we have parallel lines, theoretically. But we need to check that. So let's go back to our two lines here. We have y is equal to 2x minus 3. That means the slope for the first line is equal to 2. Let's see if we have a slope of m equals 2 for the second line. So we'll solve this second line for y. So if we subtract the 2x over, we get negative y is equal to negative 2x plus 5. Writing it in y equals mx plus b form. I have a negative y, I need a positive y, so I'm going to multiply everything by negative 1. I will get y is equal to 2x minus 5. And again, m is equal to 2. Okay, so the slopes are equal, which means these two lines are parallel to each other, which means we have an inconsistent system. There's no intersection between these two. All right, cool. So that gives you guys an example of some of those tricky ones that you guys see earlier on that sheet of paper. Okay, let's go to our next page here. This will be our last page with substitutions, and then we'll switch to a different video for doing elimination. So for this one here, so if x is equal to 3y plus 1, so x equals 3y plus 1, and then 2x minus 6y is equal to 2, we want to solve the system. So again, we already solved for x. We'll plug this value in for x, and then we're going to solve for the point and see what we end up with. So I'm going to pause the video again, and you guys can come back. Okay, so we've simplified this one. We solved for x, or I'm sorry, we were given x. We plugged it in for 2x minus 6y is equal to 2. So you get 2 times 3y plus 1 minus 6y is equal to 2. Distribute the 2 through. You will get 6y plus 2 minus 6y is equal to 2. The 6y's will cancel because they're negatives, and we're left with 2 is equal to 2. Well, that is a true statement. It's not like the last problem where we had 3 was equal to 5, so that's a good thing. But we are missing something here. If you look back at our earlier answers, we typically had a variable. There's no variable this time around. We're missing a variable. So what this means, this is a scenario where any answer will work, okay? Because basically both sides of the equation are always going to be equal to each other. So that implies our second scenario that we have here, where we have an infinitely many number of solutions. So we theoretically have actually the same line in both cases. So let's check that first. So we're looking for the same line. What I'm going to do, this is solved for x. We can solve it. Let's solve it for y really quick, and we can do it that way. So if we solve this for y, that will give us 3y will be equal to x minus 1. This is this line right here. Okay. Divide by 3 gives us y is equal to x over 3 minus 1/3. So this is the line we are looking for when we solve this other equation. So the first thing I'm going to do with this equation here is that we're going to solve it for y. We're going to isolate for y again. So we're going to get negative 6y is going to be equal to negative 2x plus 2. So I've written it more or less in y equals mx plus b form. Okay? And now I'm going to divide everything by negative 6. So that's going to give me y. Negative 2 divided by negative 6. The negatives can't... Actually, let me write it out for you. Negative 2x divided by negative 6 plus 2 divided by negative 6. And we'll simplify it out. The negatives cancel. The 2 goes into 6 3 times, so we're going to end up with x over 3. Then we have a minus here, so this plus becomes a minus. 2 divided by 6 is 1/3. And these two lines are the same. Oh my god. Alright, so we ended up actually with two different looking equations that in the end actually turned out to be the same equation. So this is the, what do we call this one again? This is the dependent scenario where we have an infinite number of solutions. So basically any x value you plug into this is going to work out to the same thing, and you have an infinite number of solutions. Yay! Alright, so that takes care of substitution. We're going to go to another video to do elimination, and we'll move on from there.